In this video, we will look at using the cosine and sine functions to model circular motion in situations where the vertex of our angle is not at the origin. So consider the following context. We have an angle with a measure of 1.1 radians, and its vertex is at the point 2, 1. Circle with a radius of 2 units is centered at the vertex of the angle, and we want to know the location of this terminal point. So we want to know these xy coordinates. So first of all, the radius of our circle is 2, and our angle has a measure of 1.1 radians. So we should feel tempted to write something like 2 times cosine of 1.1. If we do 2 times cosine of 1.1, that gives us a value of about 0.907. Now, what that number, we need to decide what this number tells us. What is this 0.907 telling us? Recall that the output of the cosine functions gives us a distance to the right of the center of the circle measured in radii. And since the radius of the circle is 2, 2 times cosine of 1.1 should give us the terminal point's distance in units to the right of the center of the circle. So if we look at our diagram, the terminal point's distance to the right of the center of the circle is right there. So this blue vector represents that distance. And that distance right there is that 0.907. So that 0.907 gives us a distance to the right of the center of the circle. But we notice that the center of the circle is already 2 units to the right of the y-axis, based on where that vertex of that angle is. So from the y-axis over to the center of the circle, or that vertical diameter, that's already a unit of 2. So we start with 2 units away from the y-axis, and then we have an additional 0.907 units to the right of that, and therefore the x-coordinate of that terminal point should be the 2 plus the 2 times cosine of 1.1, or that 0.907. And that gives us a value of approximately 2.907. If we look back at our coordinates system, the x-coordinate is a little less than 3, so we're doing pretty good there. Now on the other hand, if we write 2 times sine of 1.1, that gives us a value of about 1.78. And what we're computing with 2 times sine of 1.1 is the terminal point's distance above the center of the circle. So it gives us that distance right there. However, that horizontal diameter right there is already 1 unit above the x-axis, because this vertex of this angle has a y value of 1. So to get the y value of that point, we have y is equal to the initial 1, and then plus the 2 times sine of 1.1, and that gives us a value of about 2.78. Again, if we look back at our diagram, it looks like our value is pretty good. So in this case, we can say the xy coordinates are about 2.907, comma 2.78. And these two expressions right here computed those coordinates. Okay, let's look at one more example. Our vertex of this angle is still at 2, 1. The only thing that changed was the angle measure here. So now our angle has a measure of 5.5 radians. So if we write the expression 2 times cosine of 5.5, that expression right there should compute that distance, the distance to the right of the center of the circle. We know that distance is already 2 units to the right of the y-axis. So we're already 2 units to the right. So the x-coordinate of that point should be the 2 plus a 2 times cosine of 5.5. If we plug that into our calculator, we should get a value of about 3.417. In our diagram, that looks pretty good. Now on the other hand, 2 times sine of 5.5 should give us the terminal point's distance above the center of the circle. That's actually going to be a negative number because that terminal point is below the center of the circle. However, we still start with y equals 1. We start at y equals 1, and then we just change downwards by that negative number. So we still start at 1, and we change by this 2 times sine of 5.5, and when we do that, that gives us the y-coordinate of this point. So if we plug that in, our calculator should give us a value of about negative 0.411, which in the diagram looks about right. So in this case, we have the x and y coordinates of this terminal point. Our process looked very similar to what it did before. We still used two expressions that looked very similar. The only thing that changed in this case was the angle measure.